Hello and welcome to my channel, Homemade Mathematics. Today we are going to be looking at the first episode of my new Quadratic series. I've been getting so many requests and questions about quadratics, I thought it was time to create a series for it. So I do already have two videos out there on quadratics. One, finding the solution in ax squared plus bx plus c form, where a is 1, and then also same thing, but where a is not 1. Right, that's going to be very similar to finding x-intercepts because finding x-intercepts is actually finding the solution. This is going to be a 4-part series which will help you graph a parabola or quadratic completely by hand. Starting with today's video, finding the x-intercepts. Then next, we'll learn how to find the y-intercept. Then the vertex, so the highest or lowest point of our parabola. And lastly, we're going to put that all together to see how we could easily graph a parabola by hand. Make sure you subscribe so you don't miss the other videos in the series. So before I show you how we can find the x-intercepts by hand, I first want to go over the different types of solutions we could have. You can see here in the first one, it crosses our x-axis at 2 different points, so there are 2 solutions. In this second problem, you'll notice our vertex, or our lowest point of our parabola, is on the x-axis, so it means it only crosses once, and it's 1 solution. And lastly, you'll notice this parabola does not cross our x-axis at all, so it is no solution. Now let's take a look at what this looks like algebraically. All right, so I have 5 examples here, and we are going to find their x-intercepts by hand. So I always suggest that you check these with a graph, especially when you're starting out. That is an easy tip, and I'll show you the graphs for each of these after and how you could check that. But this is going to be going through the algebra process of how to solve it by hand. All right, as you saw in those graphs, our x-intercept is whenever y is 0. Right, it's either moving right or left of 0, 0, but it's not moving up or down at all. So that means our y is equal to 0. So I can rewrite this equation, and instead of y, we know y is going to have to equal 0 for it to be an x-intercept. From here, you are going to want to factor this, which I will go ahead and tag the video of how to factor when you don't have a number in front of x squared, aka 1, and how you would do that. But pretty much you're looking for 2 numbers that multiply to give you your constant, so negative 15, and add to give you 2. So I usually start by listing the factors. And since it's negative, we know one of the numbers has to be negative and one has to be positive so that they multiply to get us a negative 15. And then we also want them to add to get us a positive 2. So we know we want our bigger number to be positive. So that would be a positive 5 and a negative 3, right? 5 times negative 3 gets us negative 15. 5 plus negative 3 gets us a positive 2. So then I'm going to rewrite it. And then we can use the 0 product property, which tells us we can set both equal to 0. So we're going to end up with 2 answers and go ahead and solve those. All right, and then remember we want x-intercepts, so we're going to want to write these as ordered pairs. So we know one of our x's of our ordered pair is going to be negative 5. And then remember, with an x-intercept, our y always equals what? 0. So negative 5, 0. And same thing, but for our x is 3. And that is our 2 x-intercepts. Let's look at that on the graph and check our work. Like I said, this is a great way to check your work, especially when you're starting out. So I just typed in the equation onto Desmos calculator, and I can see that there are 2 x-intercepts at those points, negative 5, 0 and 3, 0. So I know I did it correctly. So with number 2, you could factor that if you wanted, but there's actually an easier way. We're going to just go ahead and solve for x, because remember, to be an x-intercept, our y has to equal 0. So we're just going to change it to 0 equals x squared plus 16. And then I'm just going to solve for x. So I'm going to subtract 16, and we end up with x squared equals a negative 16. The opposite of squared is square root. So if we want to get x by itself, we would have to square root and then do it to both sides. However, we cannot have a negative square root. That will actually get us an imaginary number, which is a whole nother lesson for another day that we're not going to get into. So this would actually be no solution, which means it does not have an x-intercept, which if we look at the graph, that makes sense. Again, I just typed the original equation into my Desmos calculator. You can use any graphing calculator to do this. But if you look at my x-axis, you're going to notice the parabola does not ever cross it. All right, my vertex is actually 16 points above the x-axis, which means it's never going to cross and there are no solutions. And then number 3, same thing, you could factor it if you wanted to, but let's just go ahead and solve the same way we did number 2. Except for this time we are going to have to add 16 to both sides so that we end up with x squared equals a positive 16, which we can take the square root of, right? Square root of 16, it could be a positive 4 or it could also be a negative 4. So our 2 x-intercepts, just like number 1 had 2 x-intercepts, is going to be a positive 4, and then remember in an x-intercept, y is always 0, and negative 4. Let's take a look at what that looks like on the graph and double check we got it right. So this time our vertex is at negative 16, which means it does cross at 2 points, that positive 4 and negative 4. All right, number 4 looks slightly different because it's f of x equals x plus 7, and then that's the whole thing squared, not just x squared, but x plus 7 squared. So we can't just do x squared 7 squared. It's x plus 7 times x plus 7. We'd actually have to FOIL that out, which you could do, but there's actually an easier way because we know f of x really means the exact same thing as y, which we know to be an x-intercept, y has to equal 0. So same thing, we can do 0 equals x plus 7 squared, and then we solve. So to get rid of squared, we square root. Square root of 0 is just 0, and then solve for x by subtracting 7. So you'll notice with this one, we only got one answer, which we need to write as an ordered pair, right? Our x is negative 7, and in an x-intercept, our y is always 0. So this time we only got one x-intercept. Let's see what that looks like. In this example, our vertex and our x-intercept is actually the same thing. Notice our lowest point is on the x-axis, so it's only going to cross at that one point because it just goes up from there. It's never going to come back down and cross again. All right, and lastly, again, f of x is the same thing as y, which in an x-intercept is going to equal 0. We actually have two different parts. We have x, and then we have x plus 4. All right, just like in number 1, when we had the two parts and we set them both equal to 0, same thing here. We're going to set our first part and then our second part. All right, so we already got our first answer is 0, which would be the coordinate 0, 0, the origin. And then the second one we can solve quickly here. We get negative 4. All right, again, getting two answers. Let's check it. And we can see here the vertex is below the x-axis, and we have those 2 points at negative 4, 0 and 0, 0.